Opties! Today we're going to be looking at Khan Academy with some help with Israel. This is my fiance. Super excited to look at dilations with him in this video. And I think it's really going to help you all learn as he learns dilations.
That's right.
Are you ready, Israel?
I'm ready. Let's go.
Let's do
this. All right, so I'm ready to do this. So we're doing dilate points, correct?
Yes.
All right, that sounds good. I have no idea what dilate points is. I don't really remember doing this. Can you please give me a quick tutorial on this?
I can. So simply put, a dilation is getting bigger or smaller, but keeping the same shape. So changing size, keeping shape. With a point, all points are the same shape, so it's pretty easy to do. So you've got a center of dilation. In this case, it's point P because it says keywords about point P.
Okay, so
that's where you start.
You always center a dilation. Is that correct?
Yeah, I mean, you can call it a center of dilation. It's the point that you're dilating from. So it's always your starting point, basically.
So is it for all cases or just this one case?
All cases, when you do any sort of dilation, there is a point or center of dilation.
All right.
And there's some sort of thing you want to dilate. In this case, we're going to dilate a point D. It's called our preimage because it's the first picture we're beginning with. Now, when it says plot the image of point D, image is fancy word to say the picture you get after you do something. In this case, dilate our preimage point.
Hey, what's another word for dilation?
You could call it a reduction or an enlargement. Dilation is
reduction, enlargement, and antonyms. Are they the same?
Well, there's two different ways you could talk about a dilation. If it's getting smaller, it's going to be called a reduction.
Oh, okay, gotcha.
If it gets bigger, it's an enlargement.
Ah, I see. Okay.
And we got some scale factor which tells us how big or small we're going to get. And
also, if it's a fraction, and we know it's going to become smaller.
Right. If it's a fraction that's between 0 and 1, yeah. I mean, you could have a improper fraction which would be bigger than 1, but yeah. General terms, yeah, most fractions you're going to look at are probably going to be like making it smaller. So based on what it just told you, reduction or enlargement, since this is going to be getting smaller by 1/3, is that going to be a reduction or an enlargement?
I think it's going to be a reduction.
Why?
Is that correct? Because it's a fraction. It's 1/3 between 0 and 1.
Yep. Reduction means getting smaller. Perfect.
So if it's a whole number, it'd be an enlargement.
If it's a whole number, as in a whole number bigger than 1. Yeah.
Bigger than 1.
If it's 1, then it just stays the same. Okay, so let's solve this actual problem here. It says, plot the image of point D under a dilation about point P with a scale factor of 1/3. Okay, so we've got these 2 points. Which one do you think is the center?
P is the center.
You're right, and we can double check that because it says about point P right here. When it says that fancy word about, that is a good clue in that we're looking at the center there. Okay, and we know that D is the preimage because we want to plot the image of point D. So D would be our preimage then. These are just some good words for us to remember what the points do. All right, so the 1/3 comes into play when we want to take 1/3 of the distance between our center and our preimage.
Okay, so what I would do, repeat the question.
So we're going to dilate the point D, and essentially what that means, since we have a scale factor of 1/3, is we're going to plot the point that's 1/3 of the distance from P to D. Okay, so we've got the distance, like a line segment distance, from P to D. Okay, Israel? Which one do we say we start with, the center or the preimage point?
The center.
Yes. Now that means that from the center to the point we're going to plot here, the distance from the center to the point is 1/3 of this total distance.
Gotcha.
So, Israel, what do you think we might do to find that point? Like, what maybe first step do you think you might try?
Okay, well, if I was to do something first, I would try to find the 1/3 of the distance going down.
Okay.
vertically, right?
Yeah, that sounds good.
Okay, going down vertically, so I find the distance there.
Okay.
And then I will then take 1/3 of that distance.
Okay.
And then I'll do the same thing for horizontally for D.
All right.
And then I'll take the 1/3 of that distance. Then I can use the rise over run method.
Sounds really good. I like that because any diagonal distance, you can basically find that by doing the rise and run, or the horizontal and vertical distance. That's kind of everything that the Pythagorean theorem talks about.
Yes, because I was gonna say Pythagorean theorem, but find the Pythagorean theorem and then 1/3, then multiply by 1/3. That would also give me my center, right?
That will be the perfect thing to do if the question was asking you what's the length of 1/3. But you don't actually want to know the numerical length. You just want to find the position of the point.
Okay.
But you do need to do that in some cases, so it's really good to keep in mind.
All right. I just have a rise over run because of the Pythagorean theorem.
Perfect. Yeah.
That's what I thought.
Any diagonal distance can be, you can travel there by going vertical and horizontal distances. Okay, so let's count this vertical distance. And we can actually start plotting the point and count. That might be a really good way to do it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 from P to D vertically. Let's count the horizontal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this is 12.
All right, so what I will do is multiply by 1/3
Okay.
on the vertical and horizontal.
Okay.
And the final answer will be for 9 will be 3.
Yep.
And for D be 4.
Yep. For 12, it's 4.
Mhm.
Okay, so what are we actually going to do with the 3 and the 4 now that we found them?
We're gonna use it as the rise and run.
Great. Okay, so where do I start?
So I'll start from P,
Okay, so I'm just
and
going to move this point.
I'll go down 9. I go down 3,
Yep.
and then I'll go over 4.
Oops, so we start 3, go down 3, and over 1, 2, 3, 4.
There it is, and
Okay.
that's it.
You want to know a cool way how to check that you've done it in 3 equal chunks?
Yeah, go for it.
How about we plot another point that has just copied that same rise over run? So if we go down 3 and over 4 again, and then do it another time, down 3 over 4, we end up at D.
All right, nice.
And don't those chunks look equal? That's a good way to tell.
Yeah, they do look equal, yeah.
But for our final answer, we just want that first point. So let's take this guy and get rid of him.
Okay. Yeah, that seemed pretty easy.
Good. You want to check to see if we're right?
Yeah. So to recap, what you do for problems like this that have 1/3, there is a fraction between 0 and 1. It's gonna reduce it. You start
Right.
from the center, which is P.
Mm-hmm.
Then you can do the rise over run method, which is what we just did, right? Which means that we're gonna calculate the distance between the vertical side and the horizontal side, find the distance, and then multiply that by the factors.
Yes, and it doesn't matter what kind of scale factor it is. You can always find that rise and run and multiply it,
All right.
even if it's like bigger than 1. So
Even
let's,
if it's bigger than 1.
yeah, let's do what's next. Okay, so let's do one more problem, and this one is good to do because it's got a few differences than the other one. One difference is that we're on like a grid where it actually has X and Y for numbers, like the X and Y axes. So you notice that. And also the scale factor is 4, and that's gonna give us which one, Israel? Can you tell us?
So this one's gonna enlarge it.
Yeah, awesome. Enlargement. That's exactly what I was gonna ask, if it's a reduction or an enlargement. So it's great for us to also see us do an enlargement.
But this one doesn't have 2 points like the other one.
Right.
This only has B. Would that be the center then? Or is it different?
It's not going to be the center. Let's read
Okay.
this to figure out.
All right.
Plot the image of point B under a dilation about the origin 0, 0 with a scale factor of 4.
It doesn't say like the other one said about. All right. What was the keyword for the other one?
About. Look right
About.
here.
Oh, well, that one has about. But what was the keyword that you said to know if it's a center?
About.
Oh, so the origin in this one is 0, 0.
Yeah.
Gotcha. About. So that's where you.
Yep.
Gotcha.
So this is our center. Let's go ahead and plot it so we can keep it in our minds.
Yeah.
So,
But we're gonna remove it after.
we want to remove it before we submit our answer because we only want 1 point on our actual grid. But it's good for us to look at it.
Cool.
Your center could be really anywhere, but it's really nice when they put it at the origin. It makes just things a little bit easier.
Mm-hmm.
And I'll show you why. But first, I want us to kind of do it like we did the other one. Like, we won't actually use these numbers yet, and then I want to show you how we can use the numbers. So, let's use rise or run again, like we did the other time. So the original rise of a run from the center to the pre-image point is up how many?
1.
And over how many?
1.
Yeah. So up 1, right 1. So it's a rise of a run.
And then we want to double that well, we don't want to double. We want to factor it 4 times. So we're gonna go again 4 times.
Yes, exactly right. We want to do that rise and run.
4 times. So I can keep going. 1 over 1, 1 over 1, 1 over 1.
Yes, we basically exactly what you said. You could take it and copy that. There's 1 rise or run. Here's another.
Do it again.
Here's a third one, and here's a 4th one.
Yeah, 4 times.
So we've done it 4 times. We've copied it 3 times, but totally we have 4 of those exact distances.
Okay.
We could also check those are diagonals. 1, 2, 3, 4 diagonals. But of course, the rise over run, we could copy that. We've got 4 totals, starting at the center and going to that image point. You know how we like multiplied the distances by the 1/3? Well, that's what we did here. And since we started at 0, 0, and the pre-image point was 1, 1, we could multiply each of these points by the scale factor to get the new point. So what is this point that we just plotted over here?
4 over 4.
4, 4, yeah. And notice if you did 1 times the scale factor 4 and then the other 1 times the scale factor 4, you do get 4 or 4. So you can also do that multiplying kind of thing with the grid, but it only works this way if your center is the origin. Otherwise, like you're not starting at 0, 0 and the distance is kind of like, it's kind of off.
Okay.
But if your center is the origin, it makes things really nice. But you can always do it based on just looking at it like we did the first one. So
sounds good.
Let's check. And we're good.
Good. I like this. It's pretty simple to understand and figure out once you understand where the origin is, where the center is, and how the scale factor works as well. And then using the rise over run method, that was pretty easy.
Yeah. That big things to keep in mind is make sure that you're starting at your center and make sure you know which point is your center.
Yeah.
And make sure that you are doing the correct distances. So finding the correct original distance from your center to your pre-image point by doing that rise over run. And then you can multiply by that or just kind of like copy it. Like when we did 1/3, it's probably a little easier to multiply because those are bigger numbers. With this one, since it's so small, it's really easy to just copy that rise over run visually. So either way works. Okay, Opties, I'm so excited we got to learn about dilate points together with me and my fiance Israel. Israel, what'd you think?
Well, I thought it was pretty good. At first, I thought it was gonna be hard because I didn't know exactly where to do or where to start. But once you kind of taught me the steps and stuff, it was a lot easier to tackle the problem. But yeah, but at first it looked very challenging, and I didn't think I was gonna get to understand it as fast as I did. But thanks to my previous knowledge in math and knowing how to do the Pythagorean theorem and even the basics of fractions, I understood when you multiply something by a fraction it becomes smaller, and when you have a whole number and you multiply that becomes larger. That helped a lot. So the basics. So a tip for you guys is to make sure you guys, if you can't do these problems, go back to the basics. Sometimes that will help. Like, challenge yourself to be good at the most basic stuff, so when you get these hard things, you can just remember how to break a problem with the previous knowledge you had. So something like that. But that's what I did for this problem. How I tackle it.
That's awesome. Yep, good stuff, y'all, and we're gonna get into more dilation soon. See you next time.
See you.